Most people think chatbots and AI agents are the same thing, but they are not. One just talks, the other acts. And in this video, I'll show you the exact difference. We are going to build an AI that can reason, remember, use tools, and solve problems on its own. And the best part, we're not using any complex frameworks like LangChain. This is pure Python and the Gemini API, so you'll understand exactly how it works under the hood. By the end of this video, you won't just know what an agent is, you'll have built one. Let's get started. Before we write a single line of code, we need a blueprint. Every powerful AI agent, from the simplest to the most complex, is built on four core components. First, you have the brain. This is our large language model. In our case, Google's Gemini is the part that thinks, reasons, and makes plans. We guide it with a system prompt, which is basically its job description. Next, you have memory. A brain is useless if it forgets everything instantly. Memory is simply our chat history, allowing the agent to understand the context of our conversation. Third, and this is crucial, you have the hands. The brain can think, but it can't check the weather or browse the internet. We give it hands in the form of tools, Python functions that let it interact with the real world. And finally, the part that ties it all together, the engine. This is our main Python loop. It's the orchestrator. It takes the brain's plan, tells the hands to execute the right tool, gets the result, and feeds that new information back to the brain. This is a reason act cycle, and it's what makes an agent truly autonomous. We're going to build our agent in four simple stages, adding one of these components at a time. Before we build the brain, let's do a quick housekeeping check. I've already set up a Python virtual environment and installed the necessary libraries, specifically Google Generative AI and python.env. I've also created a .env file to keep my secrets safe. This is where I passed my Google Gemini API key. Never hardcode your keys directly into the script, or you might accidentally leak them to the world. Now let's write the code for component 1, the brain. We start by importing our libraries and loading that environment variable we just created. We configure the Gemini client with the API key so it's ready to talk to Google's servers. Here is our class, agent version 1. In the initialization, in it, we define the model. I'm using Gemini 2.5 Flash because it's fast and efficient. Crucially, this is where we give the agent its system instruction. Think of this as the persona. We are telling it, you are a helpful assistant that breaks down problems. This guides how it behaves for every single interaction. Next, we have the chat method. This is the simplest form of an LLM call. It takes the user's message and sends it directly to the API using generate content. We set the temperature to zero point 0.1 to keep the answer factual and consistent. But notice something missing here. We are only sending the current user message. We aren't sending any history. This means our brain has total amnesia. It treats every message as the very first time we've met. Let's see this in action and see why it's a problem. I'll tell the agent I have 4 apples. It responds nicely. It understands the statement. But now, if I follow up and ask, how many apples do I have? Look at that. It doesn't know. It says it doesn't have access to my personal details or previous context because we didn't build a memory system. The brain forgot the first sentence the moment it finished answering it. This is the limitation of a raw LLM. It can think, but it can't remember. To fix this, we need component 2, memory. To solve the amnesia problem, we need to upgrade the agent version 2. We don't need a complex database for this. We just need to keep track of the conversation history. Fortunately, the Gemini SDK makes this incredibly easy. In our init method, we add one crucial line. Instead of just defining the model, we start a chat session using model.startChat history. Think of this chat session object as a container. It holds the model, but it also holds a list that will store every message I send and every reply the agent generates. Down here in the chat function, we swap out generate content for chat session.send message. This is where the magic happens. When we run this, the SDK automatically bundles our new message plus the entire conversation history inside that container and sends the whole package to the Gemini model running on Google servers. This gives the brain the context it needs to answer follow-up questions. Time to test the upgrade. I'll say it again. I have 4 apples. The agent acknowledges it. Now the moment of truth. How many apples do I have? And there is it. It remembers. It knows I have 4 apples because that previous turn is stored in its memory. So we have a brain and we have memory. We have a solid chatbot, but strictly speaking, we don't have an agent yet. Let me show you why. I'll ask it what is the weather in Tokyo right now. See that? It apologizes. It tells me it doesn't have access to real-time information. This is the big limitation. The brain is trapped in a box. It only knows what it was trained on in the past. It has no eyes or ears to see the present world. It can't check the weather, read the news, or search Google. To break it out of this box, we need to give it hands. We need component tree tools. Okay, let's give this agent some hints. I've created a new file called tools.py. Creating a tool for an LLM always requires 2 parts. Part number 1 is a schema. Think of this as the instruction manual. The LLM cannot read your Python code. It doesn't know what execute means. So we have to describe the tool in a format it understands. In the getSchema method, we use Gemini's function declaration objects. We tell the model, hey, I have a tool called getCurrentWeather. It takes one parameter called city, and it's a string. This method doesn't run any code. It just returns a definition. Part 2 is the execution logic. This is the actual Python code that does the work. In a real production app, this would make an HTTP request to open weather map or AccuWeather. For this tutorial, I'm simulating it with some hard-coded if statements. If we ask for Tokyo, it returns 15 degrees. If we ask for Paris, 22 degrees. Now, let's wire this into the brain. We are creating agent version 3. First, we import our weather tool. Then, in the init method, we accept a list of tools. Here is the most important line in this file. When we initialize the Gemini model, we pass the schemas into the tools parameter. We are not passing the Python functions, we are passing the descriptions of the functions. This tells Gemini, here are the tools available to you. Use them if you need to. Now, pay close attention. I'm going to run this agent and ask, what is the current weather in Tokyo? You might accept it to reply, the weather in Tokyo is 15 degrees, but watch what actually happens. It didn't give me the weather. It didn't output text at all. Instead, it sent back a function call. It's saying, I can't answer this yet, but I see you gave me a weather tool. Please run the function getCurrentWeather with the argument city Tokyo and tell me what happens. This is tool awareness. The brain has made a plan, but it hasn't acted yet. It's waiting for us to execute the code. To finish the job, we need the final piece of the puzzle. Component 4, the agent loop. This is the engine that makes the agent autonomous. Instead of us manually running the tool and passing the result back, we are going to write a loop that does it automatically. One technical detail before we start, notice this import from google.generativeai.protos import port. Gemini is very specific about how it receives tool results. We need this specific class to package our data correctly so the model understands it. Here is the heart of our agent, run agent loop. We start a loop that runs for a maximum number of turns. I've set it to 5. This prevents the agent from getting stuck in an infinite loop. If something goes wrong, inside this loop we send the current input to the agent. When the agent responds, we check, did I ask to use a tool? If yes, the reasoning step, we grab the tool name and the arguments, we look up the function in our tool map, and we execute it. Then, and this is key, we wrap that result in the part object and update next input. We are essentially saying, here is the weather data you asked for. What do you want to do next? The loop then restarts, sending this data back to the brain. If no, the answer step. If the agent didn't ask for a tool, it means it has the final answer. We print it out and exit loop. This is it, the moment of truth. I'll ask, what is the weather in Tokyo? Watch the terminal closely. Turn 1. The agent thinks. It realizes it doesn't know the weather, so it decided to call getCurrentWeather for Tokyo. The loop, our code catches that request. It executes the tool, it gets 15 degrees cloudy. Turn 2, it sends that data back to Gemini. Gemini reads the weather data, generates a natural language response, and there is our final answer. The agent reasoned, it acted, it observed the result, and it answered all on its own. And that is how you build an AI agent from scratch. We didn't use LangChain or Crew AI or any black box magic. We built the brain using Gemini. We give it memory with chat history. We give it hands with Python functions. And we build the engine with a simple while loop. Now you understand exactly what is happening under the hood of those complex frameworks. You can take this code, add more tools like a Google search tool, and build something truly powerful. I've put all this code in the GitHub repo linked below. If you learned something new, hit that like button, and I'll see you in the next one.